Hi, welcome back to my channel. My name is Gina. In this video, we're going to learn another more advanced technique to find the derivative. So before we look at the implicit differentiation, if you want to review the video, I'll put the link up there. So today we're going to learn another technique called the log differentiation. So first, let's see when will you need to use the log differentiation. So when you have y equals to a function of x to the power of another function of x. So if you have the form y equals to f of x to the power of g of x, where f of x and g of x are not constant, then we'll use the log differentiation. A quick note, you only use the log differentiation when both function f of x and g of x are not constant. If g of x is constant, then you can use the power rule, x to the power of r, where r is a constant, and its derivative is r times x to the power of r minus 1. And if the base of the exponent is constant, so this is similar to the exponential function that we derived in the last video. But instead of e in the base, now we have any constant b. And this derivative equals to b to the power of x times ln of b. In the last video, we've proven the derivative of e to the power of x, and this is a special case of b to the power of x. So using this formula, derivative of e to the power of x is e to the power of x times ln of e. And since ln of e equals to 1, so derivative of e to the power of x is e to the power of x. Here are the 3 steps of log differentiation, and when you have a function of the form f of x to the power of g of x. So first step, you'll take ln on both sides. So ln of y equals to ln of f of x to the power of g of x. And then the second step, use the rule of log to bring the exponent g of x in front of ln. So the right hand side equals to g of x times ln of f of x. And then the third step is to use the implicit differentiation to find y prime. Since here you have an equation that involves x and y, and you can assume that y is a function of x, so you can use the implicit differentiation to find y. So here are just some recap for the steps of implicit differentiation. So first, you'll take the derivative on both sides with respect to x. And note that since y is a function of x, so whenever you take the derivative of y, you have to use the chain rule. And then you'll solve for y prime. And since at the beginning you have y equals to a function of x, so you can also substitute the y into the equation. Now let's look at an example. Y equals to ln of x to the power of x. So here we have the form of f of x to the power of g of x, where f of x is ln of x and g of x is x. So they are both functions of x and they are not constant. So here we'll need to use the log differentiation. So the first step is to take ln on both sides. So the left hand side is ln of y and the right hand side is ln of x to the power of x. Then we use the log property to bring the exponent x in front of ln. So this equals to x times ln of x. And now this equation involves x and y. So to find y prime, we'll need to use the implicit differentiation. So we're going to take the derivative on both sides. On the left-hand side, we have derivative of ln of y, which equals to derivative of the right-hand side. So d over dx of x times ln of x. So the left-hand side, derivative of ln of y. Derivative of ln of x is 1 over x. But here, instead of x, we have y, a function of x. So we're going to use the chain rule. So the left-hand side is 1 over y times derivative of the inside function, y prime equals to derivative of the right-hand side. On the right-hand side, we have a function of x times another function of x. So we'll use the product rule. So this equals to 1 times the second function, ln of x, plus the first function times derivative of the second function. The second function is ln of an inside function, ln of x. So here we need to use the chain rule. So its derivative is 1 over the inside function, ln of x, times derivative of the inside function, which is 1 over x. And this x can cancel out with the x in the denominator. So this equals to ln of x plus 1 over ln of x. Now we're going to isolate for y prime. So y prime equals to y times ln of x plus 1 over ln of x. Now we can substitute the y back to this equation. So y prime equals to ln of x to the power of x times ln of x plus 1 over ln of x. Now let's look at another example. Here we have cosine of x squared minus e to the power of 4x squared and whole thing to the power of sine of x. So here again, we have a function of x to the power of another function of x. So again, it's in the form of f of x to the power of g of x. So here we'll need to use the log differentiation to find y prime. So the first step is to take ln on both sides. Ln of y equals to ln of the right-hand side. Cosine of x squared minus e to the power of 4x squared and whole thing to the power of sine of x. Now we use the log property to bring the sine of x in front of ln. So this equals to sine of x times ln of cosine of x squared minus e to the power of 4x squared. And then we'll use the implicit differentiation to find the y prime. So we're going to take the derivative on both sides. So the left-hand side is derivative of ln of y, and the right-hand side is d over dx of sine of x times ln of cosine of x squared minus e to the power of 4x squared. The left-hand side, ln of y, and its derivative we have to use the chain rule since y is a function of x. So the left-hand side is 1 over y times y prime. Now the right-hand side, here we have a function of x times another function of x. So we'll use the product rule. So derivative of the right-hand side is cosine of x, which is the derivative of sine of x, and then times the second function, ln of cosine of x squared minus e to the power of 4x squared. And then plus the first function, sine of x, times the derivative of the second function. And the second function is ln of an inside function. So its derivative is 1 over the inside function. So 1 over cosine of x squared minus e to the power of 4x squared times derivative of the inside function. So the inside function we have cosine of x squared, which is cosine of an inside function where the inside function is x squared. So this equals to negative sine of the inside function, x squared, times derivative of x squared, 2x. And then minus derivative of e to the power of 4x squared. So the inside function here is 4x squared. And derivative of e to the power of x is the same. E to the power of 4x squared. and then times derivative of 4x squared, which is 8x. So now let's isolate for y prime. So y prime equals to y times the whole thing here. And I can substitute the y back to the equation. So y is cosine of x squared minus e to the power of 4x squared to the power of sine of x. So that's the y. And then we continue with the equation times cosine of x times ln of cosine of x squared minus e to the power of 4x squared. And then we can factor out the negative sign here. So the second term is negative sine of x times 2x times sine of x squared plus 8x times e to the power of 4x squared over cosine of x squared minus e to the power of 4x squared. And that is the end of the video. So far we already covered all the derivative formulas and derivative rules and the 2 more advanced techniques to find the derivatives. If you have any questions, feel free to comment below, and I'll see you in the next video.